Good morning, young friends. Our subject is manufacturing processes 2 and our module is ongoing general purpose machine tools, and today is the last lesson under this general purpose machine tools. Topic today is broaching, principles, systems and applications. Now, what are the content within this course, this today's lecture? This lesson will enable the students state and visualize the principle of broaching. Next, describe construction and functioning of broaching tools. Now, I tell you that broaching is a machining process and broaching tool is a kind of cutting tool simply called broach. Then this lesson will also enable the students illustrate different broaches and their applications, classify broaching machines with respect to configuration and use, identify the advantages and limitations of broaching process. Now, let us discuss the basic principle, why it is so novel, why it is so modern and very much attractive. Here, suppose this is a job, okay? This is a job means here is a block, a rectangular block, and suppose we have to cut a slot like this. Here a slot has to be cut onto this. Now, this is the block from this side, it looks like this. This is the job, and now this has to be, this slot has to be cut. Okay. Now, this slot has to be cut by suppose the shaping tool, this shaping process. So, it has to be cut since the depth of the slot is quite large, it has to be removed layer by layer in thin layers. Okay. So, you give a small amount of depth, then you give further depth to the shaping tool, after it comes back you give the feed again. So, this is gradually in feed is given down to complete the total depth. Why it is done layer by layer or with a small load on the tooth? Because if you try to cut the entire material by this single pass, then enormous force will come onto the tool and tool will break. So, to enable this cutting tool to withstand that amount of force that will be coming, it is allowed to cut layer by layer, thin layer. So, the cheap load or cutting force on the cutting tool will be less. So, the total depth will be completed in number of passes, so that the tool is not subjected to very large force, so that it breaks. Now, here you can see that the productivity of such system is very low, because the tool cutting tool moves forward to remove the material, starts from 0 velocity, reaches with 0 velocity, then returns, that is idle stroke. Now, so much time gets wasted during repetition of this number of passes, and this number of passes have to be given manually or say semi automatically. So, this takes lot of time and effort. Now, if this cutting, so these are the positions of the tool, instead we use different tools and join them like this, you join them and like this. So, it becomes a single piece, okay, having number of teeth. Now, you move straightway, then what will happen? The entire material will be removed in one stroke. So, lot of force will be coming onto the tool, but force per tooth will be less depending upon the thickness of the layer that is getting removed by each tooth. So, the force per tooth will be less, but the total force and power requirement will be quite large. So, machine tool should be strong, powerful, but the force per tooth will be reasonably less, so that it does not break and destroy. So, it looks like this apparently. So, this is the broach, okay, which has got a thickness, it is a solid piece which has got number of teeth in series, and in case of shaping it was moved gradually downward, and this amount of movement is called in feed. Now, in case of this cutting tool, this gap will be there inherent. So, all the teeth will be gradually protruding or rising. Amount of rise is called the rise, tooth rise, that is equivalent to the in feed. Here in feed in case of now this broach, this is called broaching tool, and this process will be called broaching process. Now, what is the main advantage? Very high production rate. In one stroke you produce this job. Now, this is a very simple job. This job can be very complicated, maybe a keyway or a spline or a gear teeth and various things. Okay. And finish will be better, quality will be, product will be also good. And this strip, this broach can be very large one, like a rod having number of teeth maybe up to 40, even more than 40 it can be. So, this is broach. So, this is the basic principle of broaching. Now, the continuation basic principle. Now, suppose there is an object. Okay. Here is an object where there is a hole already made by casting or say forging or some other method. Now, this has to be finished, this has to be enlarged and this has to be made perfectly circular, and the surface finish and will be good, and the dimension, the diameter will be also appropriate. Now, this is the task. Suppose this is the block where this hole has to be made. There is a pre-hole, this can be made as I told you by preforming, casting, forging, or it can be drilling also. Now, this has to finish to appropriate dimensional accuracy, form accuracy and finish. Now, here is this job is this one. Suppose this is that job, here one, and this is the hole which has to be finished, and this is the broach. Now, this is the broach of the cutter which has got number of rings, okay, number of rings, and this ring is at the edge, there is a cutting edge. So, when this will pass through that, this will remove a layer of material. Now, this has got so many cutting edges and the diameter of this cutting edge is gradually increasing. So, that and the finishing dimension will be decided by the last series of cutting teeth, and this will be pulled in this direction. So, the hole will be complete and to appropriate finish and accuracy. Now, this is pulled, it can be push type also, we can push it like this broach, and this will finish this hole. So, broach can be pull type or it can be push type. Now, next is construction and function of broaching tool. Construction, what do you mean by construction? Configuration, that is appearance, size, shape, etc. Then material, what material it is made of, and the cutting tool geometry. Now, first come to the configuration. Now, you will see later on we shall discuss that this broach can be push type, it can be pushed to the hole, it can be pulled, it can be internal, it can be external, it can be of different types. Okay. Now, most common is pull type. This is one. This is this broach shown over here, it is a single piece like a rod, all right, and it is pull type, and these are the cutting edges. This is to be used for making or enlarging holes by number of ring type cutting edges. So, this is the solid piece and rod like, which has got several features. Number in the front, this is called pull end. This will be connected with the adapter, adapter with the slide, and slide will be pulling the broach through the workpiece, all right. And this is neck portion. Here you see the diameter of the neck is much small, it is deliberately made smaller. If by chance the cutting force increases very much and there is a chance of breakage or tearing or damage of the tool, it will break here only, all right, and the entire broach will be safe. So, this is for safety purpose, okay. And this is the called front pilot. This will first enter into the hole to be finished. Now, there is a series of cutting teeth. This is comprised of two parts, roughing teeth up to certain distance where the teeth are rising sharply with the tooth rise, and then a number of semi finishing teeth with lesser tooth rise or infeed. Then a series of finishing teeth where tooth rise is less or feed will be less, thickness of the layer will be gradually less, and at the end there may be few burnishing teeth where there will be no metal removal, but some plastic deformation to give good finish and surface integrity. And the last is the rear pilot. Okay. So, this is the general configuration. Now, the material of broaches. Now, remember broach is a cutting tool as such. So, what properties a cutting tool material should possess, the same properties should be possessed by a broaching tool also. What are those properties essential for cutting tools as well as broaching? Strength under tension as well as compression and shear, hardness to prevent wear, toughness, then chemical stability against the workpiece and environment like cutting fluid, heat and wear resistance. During machining, heat will be generated and the tool material should not become soft or plastically deformed under heat, and it should be wear resistance, so that life becomes longer. Formability, yes, formability, the material should be such, especially in case of broach, because broach is a very complex integral shape of a cutting tool which is very difficult to manufacture. So, it has to be made of such a material which can be easily machined, ground, cut, hardened and so on. So, that kind of material has to be taken, so that formability is there. Availability, it should be available in plenty and cost should be reasonably low. What are those materials suitable for broaches? High speed steel, that is the best material for broaching, and then cemented carbides are also applicable, because high speed steel, though it has got all properties, but hardness is very low, hardness and wear resistance, heat resistance are low. As a result, the cutting velocity is low. If you want to increase the productivity or cutting velocity higher, then cemented carbides have to be used. Cemented carbides have to be used. Now, this is called tungsten carbide and cobalt and some other materials also there. It is used in two forms, blades, small blades which will be fitted into the slots of the broach in series, and these will be braced, and inserts are also available in the market which can also be fitted by clamping, mechanical clamping, and time to time this can be indexed, just like indexing turning tools or milling cutters. Now, this cemented carbide, even high speed steel cutters can be coated. Carbide tools can be coated with titanium carbide, titanium carbonitride, titanium nitride and so on, but if it is high speed steel, best is titanium nitride coated tool, which will give longer life and better performance. Now, geometry of broach, just like single point cutting tools, this broaching is also a tool, and like all cutting tools, it should have certain definite geometry like rake and clearance. Here you can see this is the workpiece and this is the tool, alright. This is a tool which is removing material and it is moving in this direction, that is called cutting velocity. Perpendicular to that is the reference plane. This is the rake surface of the tool along which the sheave flows. So, this is the rake surface, angle between them is the rake angle, gamma is the rake angle, which is the very vital angle for cutting tools. On the other hand, on the flank surface there should be clearance angle, so that it does not rub with the finished surface. Now, in case of broach, there are two clearance angles up to certain length called land, primary clearance, and then thereafter some secondary clearance with a larger magnitude, and this gap between the teeth is called pitch. And here you can see that the succeeding teeth is at the higher level. So, this is called rise or tooth rise. So, this will remove a layer, this will remove another layer. So, layer by layer material will be removed by the consecutive teeth. Now, what is the pitch? This is pitch. What should the value? Approximately it is stated that this pitch should be 1.25 root over L. L is the length of cut or length of the job to be cut. Suppose 25 millimeter, root over that 5 millimeter into 1.25, that is about say 6 millimeter, and this is for and it can be up to 1.5, it can be higher also. What about the number of teeth? How will you decide? Suppose this amount of layer of material has to be removed layer by layer, and number of layer means number of teeth. So, how it is to be done? So, total depth that divided by the true feed, or this true feed, this is called rise, will give you the number of teeth, and this will be equal to the length of cut divided by the in feed. Okay. Like say total depth divided by A1 is the number of teeth. Now, rake angle, it can also be decided by length of the cutter, length of the broach divided by pitch of the cutter. Rake angle, now rake angle should be, it should be positive. If it is a high speed shield, it should be positive. If it is carbide, maybe 0 also, but not less than that. So, 0 degree to up to 15 degree, it may vary depending upon the work material, tool material and cutting condition, etc. Clearance angle, primary clearance should be 3 degree to 5 degree, and secondary clearance from 6 degree to up to 25 degree. It can be quite large, the secondary clearance here. Okay. Next is broaching operation. Now, the broaching operation, what are the steps involved in broaching operation? These are selection of the broaching machine, selection of the broach or the cutter, mounting and clamping of the broach on the machine, fixing workpiece in fixtures in the broaching machine, planning tool work motions, selection of the process parameters, cutting velocity, feed, depth of cut and cutting environment, then run the broaching operation. So, these are the steps. Now, let us see selection of broach and broaching machine. Criteria of selection of broach. Now, broach is the cutting tool. There are many types of cutting tools, broaches available in the market, or you can develop as you like. And now, from those broach available, which one you will choose? What will be the criteria of selection of the broach? Those are type of the job, what kind of job you are handling, form of the job, is a circular hole or it is a surface or it is a gear teeth or it is an internal external keyway, depends size, is a small size, medium size or larger size, and what is the material of the job. These things will decide the selection of the broach. If the workpiece is very hard and strong, then carbide has to be chosen, like that. Geometry and volume of work material to be removed. Now, geometry, it is a circular hole or it is external surfacing or it is a keyway or it is a spline. Geometry and volume of work material. If the volume of work material to be removed is quite large, then length of the broach has to be proportionally longer. Desired length of stroke is a, if the length of stroke required to be large, then these broaches have to also to be longer. Type of broaching machine available. Now, different types of broaching machines are available and they handle different type or different ranges of cutting tools. If you know what kind of machine tools available to you, you can select the cutting tool in addition to considering the workpiece. Now, what are the criteria of selection of broaching machine? Type, size and method of clamping the broach. How you clamp the broach? There are different methods of clamping the broach. That system has to be available in the machine. In which machine that is available, you have to choose that one. Then size, shape and material of the job. If the job is very large, shape is very odd, then a different type of machine has to be taken. Strength, power and rigidity required for the machine to provide desired productivity. If you want high productivity, then cutting velocity has to be high, depth has to be high, in-feast has to be high, or machine tool should be strong and powerful. If you want high process capability, that is accuracy and finish, then machine tool has to be rigid. So, you have to select rigid machine tools. Now, coming to mounting and clamping a broach. Friends, there are different methods of clamping, mounting and clamping broach in a broaching machine. That depends upon what is a pull type broach or push type broach, internal broach or external broach, various types are there. But remember, broaches are mostly internal working type, okay, and they are pull type. Now, here you can see the examples of two pull type broach clamping method. This one, this is the broach, you can see, and there is the adapter. Here is an adapter which is fitted into the machine slide. This is the machine slide, this one, which slides over the guide of the machine tool, and by a pin this broach is fitted into the adapter. So, when the slide moves hydraulically preferably, then the broach will also move through the workpiece, and this will produce the necessary surface. There is another method. Okay. Now, this is the broach and this is called pull head, this one. Now, here when you fit a broach in or you remove it, then this outer socket has to be pressed in. Okay. When you press in, then these strips, these two strips, radial strips 2 or 4 will be able to go outward. So, it can enter easily or go out easily. After you put it inside fully, then you simply release this one, and this compression spring will push it outward, and then this region of this socket will push these strips, 4 strips inward, and that will hold this one by the broach by the neck. So, this is very simple semi automatic kind of holding and clamping of broach. Now, this is normally used for pull type broach. Now, coming to mounting of broach, external broach. What is external broach? That do external surface machining, like making a flat surface, or say external keyway, external splines, external gear, and so on. Suppose here this is the broach, this is the frame, and this is the broach, and this is the broach, this is a cross sectional view, and this is the broach which has got number of teeth, and this is, suppose this is the workpiece, this is the workpiece which has got a protrusion, and this has to be machined layer by layer by a broach, okay, and this is that broach. So, this will be clamp, there is a slot there. So, in the frame shown over here, there is a slot, into the slot a broach is fitted, and then there is a clamping piece which is pushed in by a Allen screw. It is one method. There is another method. So, this is external. Now, mounting of workpiece. Now, how do you mount workpiece? Now, this is so this is a workpiece where a keyway has to be cut. A keyway has to be cut inside this. So, this broach will move in this direction, and this will cut this one. So, this is this one, and this one is called guide bush, and this is the frame, and this will be pushed in, and the job will be there, and the broach is a strip type. This is the broach. If you pull the broach, then the keyway will be cut. Now, this is another method. Okay. So, this is the workpiece. This workpiece actually is like this. Here is like this, suppose it is like this. Now, you have to cut a slot, you have to cut a slot like this here, this portion has to be removed, and this can be done by a broach. Okay. So, this is the broach which will, this is the broach which will move downward, and this will produce the required cut, and the blank is mounted in this machine by this fixture. Now, remember the job mounting in this broaching machine is a mass production machine, very fast mass production machine. Therefore, these jobs have to be mounted on special type of fixtures, where the job blank can be easily, quickly, and uniformly mounted for locating, supporting, and clamping. So, this is how the jobs are mounted. Coming to tool work motions. Now, friend, I remind you that in cutting operation by any machine tool, there should be number of tool work motions, relative movement, cutting motion, feed motion called formative motions, then auxiliary motions like indexing motion, relieving motion, and so on. Now, here this broaching machine is characterized by very unique, that number of motion is only one, and that is cutting motion. The tool is normally, the cutting motion is imparted to the cutting tool, job remains stationary, and the tool moves, and the job is finished. So, this is only one motion. So, the machine is very simple. What are the process variables? Cutting velocity. Now, the cutting velocity, this is the cutting motion imparted to the cutting tool, either push or pull. Either you pull it or push it at a certain rate, that is called cutting velocity, expressed in meter per minute, and if it is high speed steel, then velocity should be 10 to 20 meter per minute. If it is carbide, then 20 to 40 meter per minute. If it is coated carbide, you can go beyond that, but mind that the machine tool should have that capacity of giving or withstanding that amount of velocity and power. Now, what is depth of cut? Depth of cut will be decided by the length of the cutting edge involved in cutting. Okay. If it is a circular hole, which has to be made by a broach in a block, then the total perimeter is the width of cut, that is the length of the cutting edge involved in machining. If it is if you want to make a slot like this, then this length, okay, total length is the width of cut. But what is feed? In case of machining like turning we call feed, but in case of broaching it is called tooth rise. It is inbuilt into the teeth, which will be 0.05 to 0.2 millimeter only for roughing and 0.01 to, that is 10 micron to 40 micron only for finishing work. It can be even lesser. Next is types of broaching tools and their use. I told you that various types of operations are done by broaching, and this range is gradually increasing day by day, because broaching process is very fast, very productive, and its process capability like ability to provide accuracy and finish are also quite high. Broad classification of broaches: internal broach and external broach. So, first classification will be whether it is internal broach or external broach. Next is pull type or push type, ordinary type or progressive type. The broach is solid type single piece, or it is sectional made of number of pieces, or it is segmented few pieces. Whether it is profile sharpened type or form relief type. This is how these broaches are classified. See some examples: internal broaching and the corresponding tools. Now, first the applications of internal broaching. What do you mean by internal broaching? Internal broaching means, suppose this is a ring, this is a ring, okay, inside which a circular hole, there was a hole initially very rough and inaccurate. This has to be enlarged by removing a layer of material, and it has to be finished to a perfect circle of a given diameter and good surface finish, and this is the corresponding broach, which will be moved through either by push or pull through this hole. So, this is making an internal feature. So, this is called internal broaching. This is another form. Okay, these various forms can be produced. Now, applications are through holes. Now, these holes should be through, there should not be any obstruction. Step holes cannot be made, or taper holes cannot be done. It has to be through straight cylindrical holes with the different profiles. Through holes of different form and dimensions, fine. Non-circular holes, this one. So, this is a non-rectangular hole. Okay. Then holes and internal slot, this is an internal slot which has to be made into the workpiece. Now, teeth, internal keyway and splines. Now, you see, this is one keyway, this is a say gear blank or a ring in, or a say pulley in which one internal keyway has to be produced, all right. It is a long keyway that has to be produced by this kind of broach. This is two keyways, this is splines, this is an hexagonal prism. So, different forms can be produced. It can also produce teeth of gears. In one stroke it can produce all the teeth in a gear, it is so fast. For example, here you see this is an internal gear having internal teeth, and this is a corresponding broach. Now, from the appearance you can understand the broaches may be of so complex shape, and they will be very difficult to design, manufacture, maintain, repair, resharpen. So, cost is very high. Now, external broaches. Previously we saw these internal broaches, now external broaches. These external broaches, they do really surfacing. It is very similar to shaping, planing, milling work, but this broaching outperforms shaping, planing and milling with respect to productivity. It works very fast. In one stroke it does the whole work, accuracy and surface finish. So, in all respect it is better than this planing, milling and shaping. applications of external broaching, unobstructed flat surfaces, it will produce flat surface. Suppose this is a block, this flat surface has to be produced, flat surface. Peripheral surface, it can be a curvature, it can be contour, it can be a contour surface, but is a through. Grooves, it can move these grooves, slots, keyways, etc. Now, here is a say, now you want to cut a slot here on this one. So, this external slot or this groove or keyway can be cut. External splines, so external splines can be cut, the grooves on the external splines, and finally, the teeth of external spar gears, both straight fluted and helical fluted spar gear, teeth of spar gears can be cut, and even gear sectors, say part of gear, say gear sector like this will be shown later on, can also be cut. Let us see the example. Now, here you can see that suppose this is a gear, okay. This is the gear, this was the gear blank, this was the gear blank. You have to produce the teeth. So, first you have to remove this layer of material, okay. This layer of material in between the tooth. How you can do? By shaping it is possible by number of passes, but if you take a strip type broach, this one, when this will be pulled through this piece, then this groove will be made. If one groove can be made, why not this groove also? Two teeth to productive, so this strip will make this one. If two, then why not for this one and this one? So, these two strips, then this strip, all the can be done by different strips, and different strips or parts broaches will be fitted into a cylinder, and when this cylinder will be pulled over this gear blank, all the teeth will be produced, external teeth will be produced with high accuracy, high finish and very fast production. This is another example. You say if you want to make cut a slot like this. So, this kind of broaching is possible, you can make a different form also, and now this is the gear sector, this is the gears, okay, gear teeth, and for cutting this one, this kind of cutter has to be used, which is conjugate, the form tools. And it is interesting to note and important to note that broaches are really form tools, most of the time is the form tools, because the form of the tool will produce the profile of the job. So, the profile of the job will be totally dependent on the form of the tool, and any defect or damage in the tool will be reflected on the quality of the or accuracy of the profile of the job. That is a disadvantage, the limitations you can say. Now, pull type and push type broaches. Pull type you have seen, okay. Now, pull type, these are more common, widely used, and these are long in size with a large number of teeth, okay. But what is push type? When you push it, it is subjected to compression. If it is a pull type, it is subject to tension. Now, if it is subject to tension, then alignment becomes very easy, and this operation is simple and there is no chance of any buckling. But if it is a push type, then there is a chance of buckling. So, push type broaches will be smaller in size, they will be more rigid and subject to lighter cut, and they will be used for outer work. Now, here you can see there is the ordinary type, their broaches are ordinary type, okay, this, and it can be progressive type. What is ordinary type? Ordinary type means, in the previous case we have seen that where there is a continuous tooth rise, the successive teeth have got some rise or incremental protrusion by which it makes. But here in the progressive type, here you can see the progressive type, this one, where not the height of the tooth is increasing, the height is not increasing, but the width is increasing. You see the width is increasing. So, gradually if you want to remove a layer of material, you can first make a slot by this one, then widen the slot and finally remove this material. So, this is called progressive type. Now, if it is a very long one, we can remove this material because this part of the broach does not work. only this end, this portion and this portion. So, this can be modified into this form, which is made of two strips. First of all, this end will enter, and gradually the width of the job will increase with the progress of push of the broach through the hole. So, this is called progressive type. Now, solid sectional and segment or module type broaches. Most of the broaches I told you are pull type and internal working type as this one. Okay. This one, this is the most common pull type internal broach with a large number of teeth in a length. This is called solid, it is a solid single piece from which it is made, mostly high speed steel. Now, this is sectional, where these are the cutting tool, okay, separate disc like, which are fitted one by one and then assembled and then tightened from this end. And when this is pulled or pushed, all these teeth will work simultaneously, and here you can see the tooth rise. These succeeding teeth are of larger diameter or larger protrusion. What is the advantage? Advantage is, if one of the tooth is damaged, you can replace it. You can replace it if suppose the diameter of the hole to be slightly increased or slightly changed in the form, then you can replace these single pieces or sections by another set. This is the advantage. Another called segmented type. If it is say ordinary type, this kind of broach for making flat surfaces and requiring quite a large amount of material removal. So, instead of making a long broach, which is very difficult to make, you make in small length and then you fit into the broach holder. So, this enables design, manufacture, mounting, repair, maintenance of broaches easier, and cost of the broach also comes down. Now, the profile sharpened and form relief cutters. You remember that milling cutters, this has got this kind of tooth and another. So, here the cutting tooth is like this. So, this is a cutting tooth flat, and another case, suppose you want to produce the gear tooth profile. Okay. So, in this case the tooth will be like this. This is called profile sharpened milling cutters, this is called form relief milling cutters, and here the tooth will be like this. This is Archimedean spiral and this is flat. This kind of milling cutters are used for making flat surfaces, and this type of form relief milling cutters is for producing forms, particular form. Similarly, the broaches can also be divided into two classes: profile sharpened type, where this will produce only the flat surface or surfaces bounded by flat surfaces, very simple, and this is flank surface is flat, and resharpening is done by grinding the rake surface, grinding the flank surface only in case of profile sharpened cutter, which is simpler. But in form relief cutters with the milling or broaching, the grinding has to be done in the rake surface, because at every point this is rake angle, clearance angle are different, which is much more complex. So, most of the tools are broaching tools are form relief type, because they are form tools. Now, coming to broaching machines, again as I told you that there are different types of broaching tools available and which can be designed and developed, and similarly the number of machine tools are also quite there, maybe say about dozen types of broaching machines are available. So, what are the unique characteristics of broaching machines? These are costly, no doubt, for different reason, but unique characteristics are only one motion. You will not find any other machine tool where motion is only one. Broaching machine is the only machine tool where the motion is only one, and that is called cutting motion and imparted to the cutting tool. But occasionally this motion can be given to the job, keeping the cutting tool stationary, but that is very rare. Now, you also know that the machining work is accomplished by producing these surfaces, which is produced by generatrix and directrix. Here In broaching machine, the generatrix always provide the tool form. The tool form acts as the generatrix and cutting motion as the directrix. Combination of these directrix and generatrix produce the all geometrical surfaces. Now, how the broaching machines are specified? Broaching machine tools type, whether it is horizontal or vertical, is it push type or pull type, means broaches handled. Maximum stroke length that can be accommodated in the machine tool. Maximum working force that will be acting on the broach. So, machine tool should be able to stand that amount of force. Maximum cutting velocity that machine tool can provide. Power that can be provided by the machine tool, and footprint. Footprint means the area of the floor space that will be occupied by the machine tool, because floor space is also very expensive, maybe as expensive as the machine tool. Now, the classification of broaching machines. Broaching machines are classified according to purpose: single purpose, general purpose, single purpose or special purpose. So, general purpose, you can change the cutters frequently. Single purpose, suppose you have to produce gear sectors, for example, in huge quantity over say years, then this machine should be a single purpose, producing only gear sectors, not doing any other thing, then the productivity and quality will be high. Special purpose, where a complicated job, say a complicated job requiring number of broaches to produce this slot and this hole finishing and simultaneously working, then this will be special type. Job requirement, internal or external broaching. So, the machine can also be classified accordingly, but there are broaching machines which allow both internal and external broaching. That is called compound. Configuration, this machine tool is horizontal. Most of the broaching machines are horizontally acting, but some of them are vertical. Number of slides, now here you see 3 operations have to be done simultaneously. So, 3 broaches will work simultaneously, called 3 stations, and for that 3 slides may be necessary. So, the single slide or multiple slide or indexable. Now, there can be a hexagonal turret, suppose, which has got 6 faces. On 6 faces the broaches will be mounted, 6 broaches. Okay. Now, here is a workpiece which will require surfacing, slotting, grooving, different things. So, this will just rotate and bring the desired broach into cutting action, and all the job will be completed. So, this saves time. Then tool work motion, intermittent motion, that is common. So, this will move either pulled or pushed, then pushed or pulled back, another job is mounted, then this is repeated, this is called intermittent type. Another one is continuous, a large number of workpieces will be moving continuously and done fast, that will give more productivity. Now, horizontal broaching machines, most of the broaching machines are horizontal type and they are used for internal work by pull type broach. For example, here this is the broach which is for internal working and this is for pull type. The job will be mounted here on the fixture, and this is a hydraulic drive ram which will push or pull this broach away or towards the workpiece, through the workpiece. Now, next is say vertical broach, the vertical broaching machine. Now, this is a hole on which you can mount a job, okay, different type of job, and the broach will be moving like this, either pulled from bottom or this will be pushed from top. So, both kind of system may be possible. Now, what are the unique features of this vertical? It occupies less floor space, it occupies less floor space. This is very important, more rigid, because the broaches are acting by the slides which are resting on the ram is moving or resting on the base, which is support, mostly used for external or surface broaching, for external work, but occasionally this can be used for internal work as well, but mostly push type broaches are used. Now, this is high production broaching. machine. Productivity of broaching machines. Now, let me remind you that broaching is a process which is very highly productive, because it works very fast, removes the entire material normally in one stroke, unlike milling or shaping or planing. All right. So, as such broaching is a very high productive and used for mass production. It also provides good surface finish and accuracy. Okay. But the production rate or productivity of even such broaching process and machines can be increased further. How? By incorporating automation. Now, incorporating automation, that is mechanization, where in mounting of the jobs. So, jobs will be quickly and automatically mounted, clamped, located, supported and clamped, and then unclamping will be also very quick, and by an ejector this job will be thrown out from the fixture. Similarly, there should be a mechanism by which this cutter can be quickly changed, okay, from one form to another depending upon the type of the job to be done. So, some kind of automation, then say entry of the blanks and removal of the blanks. So, conveyor, all these things can be automated or mechanized. Another way of increasing productivity, further increasing number of workstation or slides. Here this means that suppose this is, as I told you earlier also, this is the workpiece, a large block. Okay. Now, here you do a hole, here you do another square hole, here you make a slot like this. So, there will be number of broaches will be acting, for them different slides will be used and different stations, and then the productivity will be multiplied. Next is quick tool changing by turret indexing. This has been already mentioned that there will be a turret, and on the turret, this will be turret, a long turret, and on the turret the broaches will be fitted, okay, either clamped or it will be fixed temporarily or permanently, and job will be say placed at the bottom, and the one broach will do some work first, then this will go out, another broach will come into action, another broach will come into action. So, successively 6 broaches will come forward and do 6 different work on the job, and in one spell you can get the entire job complete. So, this way the productivity can be enhanced. Next is continuous working. Now, the continuous working, normally what we see in broaching machine, that one job is, say here is a block which has got originally a hole, and this hole has to be complete finished to appropriate dimension, finish, circularity, etc. Then this has to be clamped into fixture, and then the tool has to be moved through this either by pull or push. All right. Now, this is called intermittent, but what is continuous working? Instead of one piece, now here you see that there is a large disc, okay. There is a large disc, this one, on which these small work pieces are mounted either by magnetic chuck, magnetic force, or by clamping, and now this will rotate about this axis. Now, here is the broach. All right. This broach is a circular arc type, and at the bottom it has got cutting edges. Okay. This has got cutting edges. Now, when this will move, suppose it is moving in this direction. So, all this one will undergo the broaching action, then come out. When this will come out, then this will be withdrawn, because this is finished. Okay. So, this will continue when all this, now when this is finished, this will come into this portion, you mount another block. So, this will be a continuous process. Now, if the number piece is large, you can apply this method also. This is a chain and this is a sprocket, these are 2 sprockets, and on which a chain is moving. On the chain work pieces are mounted, identical small pieces that we mounted, produced in huge quantity. Now, when this will pass through, this is the broach. This broach cutter is fixed on a rigid frame, and when this one will pass through, they will rest on a rigid surface. So, when this will pass through rigid surface and undergo this cutting action by the broach, and this will be finished here, and you take it out and new blanks will be fitted in. So, this will give you very rapid that is mass production. Now, friend, you have heard about these good qualities, favorable qualities, that is productivity, accuracy, finish, all these things and economy, but what are the finally advantages and limitations? In brief, advantages: very high productivity. This has already been discussed. Why it is so? Because in one stroke it can finish the product, high productivity, which can be increased further by mechanization. Dimensional accuracy is also very high, and surface finish is excellent. Roughing and finishing by same tool, because the tool has got a series of roughing tooth followed by finishing and super finishing. So, you get this, all these activities in one stroke of the cutter, all right. Now, needs only one motion, there is no motion. More motions means more components, parts are involved, more wear and tear, less rigid, backlash, all problems. Since the motion is less, so the machine is very rigid and very fast, extremely economic for mass production, because it is very fast working. But friend, what are the limitations then? Whenever you get something, you have to sacrifice something. What are those? Can machine only through holes and surfaces. Now, this tape surfaces, this one cannot be removed, it has to be through. Then the hole, it cannot make, say, stepped hole it cannot make, it has to be through hole. Applicable only for light cuts, yes, the cuts cannot be very high, then this tool will break, or there is a chance of buckling and other problems will arise. And velocity is normally low, because usually it is a slender rod type cutter, and the tool is maybe tension or in compression. Tools defects affect tool quality, yes, because this broaching is a forming process. So, the profile of the job will depend upon the form of the tool. If there be any damage, defect or anything into the tool form, that will damage the tool job also. Tools are expensive, obviously it is very complex size and shape, difficult to manufacture and all these things. Friend, and separate broach for different job profiles. Now, suppose you want to produce gear, external gear or internal gear. If the number of teeth changes even by one, if the module changes, if the helix angle changes, if the pressure angle changes, a new broach has to be used. So, several broach has to be procured. This is a great advantage, disadvantage or limitations of broaching in case of such kind of applications. It will be economic only for mass production. If the production size is small, then this machine tool will not be economic, because the cost of the machine is quite high because of its process capability, rigidity, ruggedness, accuracy, alignment and all these things. So, this has to be used for large volume of production, otherwise it will not be economic. So, this has to be kept in mind, that it has to be used only for mass production, huge production, otherwise it will not be economic. Friends, you have heard lot about broaching. Now, I shall again go back to the beginning, just to tell you again and remind you that what is the basic principle and unique characteristics of broaching. Let us take an example and elaborate. Suppose this is a gear blank, okay, a disc on which gear teeth have to be produced. Now, actually we do not cut the teeth, what we remove the layer of material. This layer of material has to be removed in between two teeth, next another two teeth have to be produced. Now, this material has to be removed. How do we do that? We can do that by shaping tool, say shaping tool. Here, say this is first and next gradually you increase the infeed. So, the shaping tool, if it is a shaping form tool, then this has to be intermittently radially moved in. So, like this. Now, instead of number of passes, if we assume there are number of cutting tools, then we can simply join it. Now, it becomes a single piece, as you see, is not it? It becomes a single piece. Nicely you can see here. So, this is one tooth, then one, like that. So, it is one piece. Now, instead of number of passes, if we just push it in this direction, the entire teeth will be complete. Now, this is one. If we want to increase the productivity, why not we make another tooth gap by another similar cutter. So, where these two will move simultaneously, then why not two more? So, if you produce say 8 like this as is shown and remove these materials, then what remains in between? The teeth remains. So, there will be 2 cutting edges here, there are 2 cutting edges here, and all these strips will be fitted into a cylinder. Into the cylinder, this will be fitted, this broaches. This broach will be fitted into this thing, but this will be done very carefully and perfectly, otherwise accuracy will be lost. And now, if you move it in this direction, all the teeth will be produced in one stroke. Now, again this is a good part, that you get very high productivity in one stroke. You get a gear, you can produce internal teeth also by a rod like cutter, and dimension accuracy will be good and surface finish. But remember, if the number of teeth changes, then the entire broach has to be changed. If the module changes, then another broach has to be used. Now, the broach as such is very complex, very costly, maybe say 20,000 to maybe up to 1 lakh. Now, if you change the number of teeth or number of module or helix angle or pressure angle, any feature of the gear, a separate broach has to be procured. Now, you can understand that. So, this quick change in the product should not be allowed. So, this kind of cutter has to be used for huge mass production. So, that the cost of the tool and machine will be met by the number of pieces and cost per piece will come down. Thank you.